So, projectile motion is a two-dimensional kinematic motion where one is horizontal, where there is no acceleration, and the other one is a vertical motion which just is fully in the control of gravity. Okay? So for the vertical motion, gravity is the only thing. So acceleration due to gravity is like minus 9.81. But then the horizontal motion, the acceleration is 0, so only one equation is applicable on that side, which is x is equal to vt. That's it. So if you look at it in this manner, you can solve all kind of problems with the same approach. Okay, same approach. You can solve all the problems, and even if it's a difficult problem, you'll end up solving for it. Well, we'll work through many of those things right here. So there are two kinds of projectile motion problems. One is a horizontal projection, right? So we have, this is the first kind of projection where it's tossed up from a building horizontally and it goes down like that. That's one kind. The other kind of projectile motion is the angular projectile motion where it is going to start from one level and land at the same level. This is another one, where there is an angle, where there is a velocity of projection. And the third type is angular projection, but not landing at the same horizontal level. So you can actually project something at an angle from somewhere, and then it will go like that and come down and hit the floor. Or you can actually be throwing something at an angle to a friend who's standing on a building here, and he receives it. So you throw it and he receives it. Those kind of problems. These are all the same things, and all of them you approach exactly the same way. Make a table. Okay? Horizontal and vertical. And don't make the table a tiny one. Make it big enough. So you use the whole page, basically. And the table should be like this. Horizontal, vertical. Bigger, okay? Bigger table. And you can actually make the horizontal one a little smaller because you don't do much work on the horizontal side, correct? And give more room for the vertical one because most of the calculations you do are bigger ones using bigger equations. They're all here. This one is just using x is equal to vt. So there's nothing else that we do. We are writing an equation for t or v or x or whatever. And here we write the equations of motion, show all the substitutions and all that. So do the work in the respective columns. Okay, don't mix it up. Don't do it at a totally different place. You know why? Because we are trying to minimize the number of variables. We don't use too many variables. We look at your mastering work and you look at some of the sample problems here. They'll call like this: Vox. What are they writing that for? Because it is the initial velocity in the x direction. And here they'll write Voy, and Ax, Ay, and delta x, delta y. See the number of variables being brought in. And like that. So they bring in all these variables, and then the equation looks a little, bigger, messier. And some of them don't even write this. They write y final minus y initial. Oh, y final minus y initial. They write symbols like this. So the more symbols that are written like that, you may get more and more confused because this kind of complicates things. And that is why I stick with one variable. Initial velocity, vi. And it's vi here also. But you're writing the same variable on both sides, but understand you're writing in the respective column. So when you're writing it here, it means initial vertical velocity. If you're writing here, it means the horizontal initial velocity. So anything that you write, so if you write x here, that stands for the displacement what? horizontally. And if you write x here, it's a vertical displacement. So using the same symbols so that you don't like wander around here. In this case, displacements, x direction, y direction, whatever. And final velocity is vf, acceleration is a. We are trying to minimize the difficulty level of those variables. And the benefit is you get things faster and much easier. You're not mixing up. Now these are some of the simple projectile motion problems. Now when it starts getting more complicated, you still should be able to do it. Anything, I mean, I won't call a problem complicated. It's just that you need extra planning. You know, for example, I'm just giving an example. Your friend's truck just starts from here and accelerates. It's accelerating, or maybe going at a steady speed, whatever. It is moving, and it is gone already. And then you realize that you need to drop this bag of gold into the truck. You have to drop it there, into the truck, and the truck is already moving, so definitely a projectile motion. You're going to toss it. But remember, the truck is also moving, and you're tossing, so this is the path. You understand? So the truck is moving, and the ball is thrown in such a manner that it will ultimately come to where the truck is supposed to be after that period of time. Draw it properly, and then use the same concepts, and you'll get there smooth. Okay. Now, since there are two situations mentioned here, you may use mode equations because there are kind of more than one variable, and therefore you may use mode equations, but still you get there. Okay. So don't worry about any problem in projectile motion. All you need to do first is, what do? Draw a diagram. See the truck. This is the old position of the truck. This is where he is. That's the new position of the truck when it landed. And then draw the line. And after that you can say, oh, the truck took t seconds to go here. That means this ball, or whatever it is, it took also t seconds to land. You know? So therefore you start putting things together and go back to the table. For the truck you don't require a table, but for the projectile motion you definitely need a table to really understand how long it took, what is the component of the velocity, and so on. So we're going to discuss this in different ways. Let's find out. So in the horizontal motion or in angular motion, what is happening as the projectile is taken off? What is happening is the velocity is going to change. This velocity is not going to change because it's horizontal. This one is going to change, right? You know that. Why is this one changing and not this? Acceleration is only applied on the vertical direction, not the horizontal one. So here, the horizontal velocity stays the same. But the vertical velocity here is 0, and then it starts picking up velocities gradually. And this is the vertical final velocity. And this is the horizontal final velocity, which is the same as the horizontal initial velocity. Correct? And if it is an angular projection, you are giving a certain velocity v, and this is the angle that is normally referred to, and therefore this is going to be v cosine theta, and this is going to be v sine theta. Okay? Now, which of these will stay intact? V cosine theta is not going to change. The vertical velocity is v sine theta. This is the highest vertical velocity. And now next moment it actually kind of reduces. What is it here? 0. And then it turns around. And then finally. So what is going on with the horizontal velocity? It stays the same. Now if the question is, how fast, okay, this is how it is thrown. How fast is the ball or something moving at the very top? How fast? It's just the horizontal, v cosine theta. That's it. But it is not v cosine theta here. Here it is moving with this component horizontally and that component vertically, so it is actually having a, you have to find the resultant of those two. You have to find the resultant of those two, and that is a speed with which is, or velocity with which is moving at that instant. But at the very top, the answer is so easy. The answer is 0. How fast is something moving on the very top? It is this. Sometimes questions may need to be solved starting from that clue. Because I'll say, all right, I throw a projectile at an angle. You can do this question. I throw a projectile at an angle, right? And with a velocity of 40 meters per second. And it is seen to be moving on the very top at 20 meters per second. What is the angle of projection? See? It's moving here at 20 meters per second. But you know you shot it up at 40 meters per second. And they're asking, what's the angle of projection? Now, for these kind of problems, you don't have to really go to the table and mess your head up. You just use your concept here. What's the concept here? The horizontal component will never change, it will stay the same. And I already told you 20 meters per second is horizontal component, which means v cosine theta is 20. So which means 40 cosine theta is 20. So what is cosine theta? 20 over 40. So theta is what? Work it out on your calculator. Cosine theta is 20 over 40. What is theta? Cosine inverse of 20 over 40, which should be 60. Yeah. You can work this out? Everybody should be working it. Because the more practice you get in those kind of things, and sometimes when you work it out, you get a wrong answer. That's because your calculator is probably in the radian mode, or you didn't put the right entry. Yeah. What's the question, Tex?
Where'd you get the 40 from?
I gave you this. I said I'm throwing something at 40, but with an unknown angle. But I know it's moving at 20 meters per second on the very top. Get it? So that's all. You don't have to do anything in this problem other than saying, oh, this is 20, which means v cosine theta is 20. And you already gave me v. And boom. Over. So use your head more than just a pattern. Always, right? Use your head first. Draw it first. And then when they tell you, all right, it's moving as fast as 20 meters per second on the top, you're putting this arrow, and immediately that will strike. As soon as you put the arrow, you say, oh, isn't that the same thing everywhere? And then isn't that the same horizontal velocity here? Oh. So that's one way of doing it. So horizontal velocity stays the same. Vertical velocity is the one which is changing because gravity.
There is one of the parts on one of the mastering problems that asks for the x and y component at the point where it landed.
We're going to do it. I'm going to solve problems covering up almost here. All right. So let's go to horizontal projection problem, just for practice. All right. So quickly go to horizontal projection problem. This is 50-meter tall building. Or let me give another one. Don't write this. What is that?
Airplane.
Okay, an airplane, a bomber. A bomber is traveling at 720 kilometers per hour. A bomber is traveling at 720 kilometers per hour at some height. And it drops the bomb. It is dropping the bomb onto a target. It is dropping the bomb onto an ISIS target.
Yeah.
Where a friend of Osama bin Laden is hiding there, right? Whatever. So this bomb has to actually go and hit there. So what's the trajectory of the bomb? The bomb, as soon as it's released, The plane is flying horizontally, so when it's released, what's its initial vertical velocity?
0.
0, just like the soccer ball rolling off the right. So this is the trajectory. That's the trajectory of the bomb. And the target is 1 kilometer away. The target is 1 kilometer away. Question is, how high should the plane be flying? How high should the plane be flying in order to hit the target? You get the problem? So I've given you all the information here. The bomb is released from some height, which is what you want to find out. And it is supposed to hit the target. And the target is 1 kilometer away from the place where the bomb is being dropped. Question is, how high should the craft be flying so that it will be perfect? Of course, nowadays, it's not like this type. It is more of laser guided, and it's not purely by gravity. But this is a simple handmade bomb. All right. So what do you do in projectile motions? What kind of motion is this? Horizontal, angular, what?
Horizontal.
It's horizontal. So let's do the table. Okay. Let's do the table. Horizontal, vertical. Let's put things that we know straight away. What is the initial horizontal velocity?
7.
But remember, the unit is not something that I don't like. Because we're going to use gravity as 9.81 meters per second squared. So never keep anything else in hours or kilometers or miles. No. Change this from kilometers per hour to?
Meters per second.
What do you do to change it quickly?
That's 2.
You divide it by 3.6. That's the fastest way of changing from kilometers per hour to meters per second. Kilometers per hour divided by 3.6 gives you meters per second. Meters per second times 3.6 gives you kilometers per hour. Okay? So this is 720 divided by 3.6, which is 200 meters per second. So that is 200 meters per second. You get it? What is the initial vertical velocity? 0. What is the acceleration on this side? Negative 9.81. And what else do you know in this kind of
Horizontal.
which displacement do you know?
Horizontal.
Horizontal displacement, which is 1 kilometer. I don't want to write in 1 kilometer. 1,000 meters. So I know this is 1,000 meters. Now, in the horizontal section, this is the only equation you can actually use. I know already two things. What can you do now? Find the time. Whichever side helps you to find the time, do that first. So on this side, I can find the time. So x is equal to vt. So 1,000 is equal to 200 times t. How many seconds? 5 seconds. All right. So it takes 5 seconds for the bomb to hit the target. Now what do you do immediately as you get the time here? Put it on the other side. No, time is the only thing that's common. So if you get the velocity time here, transfer it immediately. That's an extra information on this side now. So time is 5.0 seconds. I have 3 things already on that side. And what am I interested to find? What am I trying to find out? Displacement. This one. That's what we want to find out. So, what equation connects these? Okay. Substitute stuff straight away. VIT, 0. Half AT squared, which is negative. Now, this is something that most of you have done wrong in the last test. I told you, like half of A, you don't have to write half of A all the time. You can just write this, right? So you can just write 4.9. So this is 5 squared. Okay. So some of you have made a mistake in this. You are using this equation. VF squared is equal to VI squared plus 2AX. And you know what? You put this right. You put this right. Everything's right. Plus 2AX. Guess what you did? Minus 4.905. It is 2 times 9.81. It's not half. Okay, so some of you use that thing here as well as here, and because of that you went wrong. So you're writing this instead of minus 19.62. You get it? So this is 2 times x, not 1. There are many of you who have gone wrong in that particular step. That's why it's dangerous to give you shortcuts. It's really. Okay, how much is it? It's minus
Negative 122.6 meters.
122.6 or 123 meters. Well, if you want to hit the target, you need precision too. But anyway, meters. So minus 120. What does the minus imply here?
Goes down.
Because it's going down. And so if you're told what height the bomb should release, 123 meters from the ground. You get it? So the answer for what height it should be flying is 123 meters. Pretty low flying. 123 meters is like not at all high. Yeah.
There's a problem on the homework where it's like an airplane and then there's a wind blowing from the southwest direction. Can you explain how
I will
we
get
do
there.
that?
Actually, it's one of the simplest problems.
Well, Cameron, you haven't even started.
Only one I can show you.
Okay. No, I'm saying, like, that's not your question alone. So many of you ask me the same question, confused about it. But I'm saying it's a very simple question. Just understand it properly and draw it properly, you will get there so fast. And I'll show you right now. So did you understand this?
Yes, sir.
Good.
Yeah.
But now if my question was slightly different, I'm not interested in finding out the height. But instead, I am interested in finding out what is the velocity of impact of the bomb on the target. So that is the question. All these stuff will stay the same. But the question is asking you, what is the velocity? Now, what kind of velocity does the bomb have before hitting the target? It has a horizontal component. What is the velocity there? 200 meters. So this already has 200 meters per second because that's a horizontal component that stays the same in the absence of air resistance. Now, at this point, there is also a vertical velocity, VF. We need to figure that out. If you can figure out this VF, because you know this, you can find the resultant. Okay. So VF is something that I'm trying to find out. What equation will best fit there?
VF equals VF plus AT.
Yeah, you can do that. VF is equals to VI plus AT because we have everything else. And so VF is equal to VI 0 plus AT minus 9.81 times 5. So what is the velocity final? So I'm going to reduce this now. It is negative. Yeah. Okay. So this velocity is 49.05. That is 200. So you have to find the resultant of these two. And the resultant is the diagonal. So what is the actual resultant?
It's
200 square plus 49.05 square root.
5.9.
Yeah, so it's landing on the target at 205.19. So 206 meters per second. So it's landing at 206 meters per second on the target. Faster than your release speed. It's faster because it picked up some vertical velocity as well. But then this is just the magnitude. You need to figure out the angle. The angle with the horizontal, which is the same as this angle. How do you find that angle? This angle, you can see the vertical component is 49.05 and the horizontal component is 200. Alright, the horizontal component is 200. So we know this is 49.05, which is the same as this, and this is 200, so we can use tan of this angle. See, this angle and this angle are the same. So tan of theta is equal to 49.05 divided by 200. So theta is what? 13.7 degrees with the horizontal. It's a very small angle. 13 like this, something like that. So the bomb is coming from the side. It's all because of the height. Who's first? Yeah, go ahead, Sam. Go. Make an E-hall pass. That's a problem. Yes, you? Say it again. Yeah, this is the angle is 13.7 with the horizontal. That's a horizontal. So when the bomb is landing, it's landing like this at this angle with the horizontal. Yeah.
I'm confused on how you got 206
Pythagorean theorem. Okay, I'm going to zoom that up. So this is the impact. That's impact. So that's a resultant velocity. You have the vertical component is 49.05. You have the horizontal component as 200. This 49.05. Now, to find the resultant, best thing to do is take those vectors and complete the rectangle, and then the diagonal is your answer, right? So this is 49. So this is also same thing, 49.05. And don't put minus signs in this. We already put the arrows. So you're getting this hypotenuse by using this square plus that square. Get it? So do you understand how to find the final velocity?
Yes.
Can you explain how you got the tangent again? Like, how did you know to use those numbers?
This is the angle that I'm looking for with the horizontal. And that are vertically opposite angles.
Okay.
These are vertically opposite angles. Right? And so if I have to include this and this side, which is same as this side. Any other questions on this?
So it's 200 meters in that little square because that's how far it's going in 1 second.
That's right. This is 200 and that is 49.05. And this is the resultant which comes out 206 meters per second. And then you have to figure out the angle by using trigonometry. Tan of this angle is opposite or adjacent. Okay.
And where did you get the 49 again?
Here.
Oh.
We found the final vertical velocity. So when it is hitting the ground, the final horizontal velocity stays the same. Final vertical velocity we just found out. And so we mark this 49. Any other questions? All right. Let's come to your the airplane problem. Let me go through that first, and then some of you have some other stuff. So the airplane problem. What does the question say? Can you?
For me, it was like the airplane was traveling due south at 550 kilometers an hour. And there was
Kilometers per hour?
Yeah. And then there was a wind blowing from the southwest.
From the southwest.
Yes,
No,
from
this
the
is
southwest.
this is your north, east, south, west. If the wind is coming from the southwest, and imagine you are located here, and if the wind is coming from the southwest, it's actually blowing towards you from here. And when the word southwest is put in, the angle is 45. Okay? If it is not 45, then it should mention north of this and south of this, or west of south, whatever. It's something has to be mentioned. If nothing is mentioned, northeast, 45. Alright? So south of west is here. So the wind is blowing in this direction.
At 110 kilometers an hour.
Okay, so the wind is blowing like this at 110. So we have two vectors now. This is what the plane is doing. This is what the wind is doing. Now you want to use cosine and sine rules. If you want to do resolving, then you can start off from here. Now if you're using cosine and sine rules, you got to join this vector with the other vector like that and then draw the resultant, which always you can do anyway, just to get a feel of which way is the resultant. So if the plane is going like that at 110 at 45-degree angle, the resultant is here. So actually the plane goes that way. The plane is actually going to go this way. Even though the plane is flying 550 kilometers per hour, it actually is not flying that fast because of the wind pushing it back. Okay? So this is the actual resultant. So you can actually find this by using cosine rules. This square plus this square minus 2 times this times cosine 45. Radical. You get the answer straight away. If you are looking for only the magnitude, cosine rule will be the best. Is the question asking magnitude and direction?
It wanted to know the speed of the plane.
Only
Once the wind
speed or
started
velocity?
Velocity.
If it is
The plane
velocity,
was traveling at 550 and then the wind started blowing, and it wanted to know what the velocity was after the wind started blowing.
now wind is a continuous thing. So wind is affecting the plane's movement. So the wind is blowing, it's not like, the plane starts moving and then after that, the plane is flying and the wind is affecting it straight away.
That's just what the question said. It just said that a wind begins blowing at 110.
Begins?
Yeah,
Did they use that word?
yeah, I'm pretty
I
sure.
remember that one.
When wind
I
begins
remember the
blowing from
question
the
that,
southwest, speed of 110 kilometers.
That is fine. That is fine. So initially it was going straight, initially it was going south, and then the wind comes into effect, and the question is, what is the new velocity, right? So that's fine. Whether it begins at a later time, that's still fine. Because due to the wind, what is the new velocity of the plane? That's the question. So if you want to find this speed, simple. Use the cosine rule and get out of it much faster. If you want velocity, then you have to figure out angles as well, and that's when you need to use sine rules. So in that case, the best thing to do is to go by method of resolving. So let's go by method of resolving. I'll call this, horizontal, vertical, or x and y. You can call it any way you want. X component, y component. For this vector, what is the x component? And y component? Negative 550. Now, these are things that should be taken care of. Now that's 550 kilometers per hour. I'm leaving it there because your answer also will be in kilometers per hour. Okay. Now when you are mixing this speed with acceleration due to gravity and stuff like that, then you have to change. Otherwise, you don't have to. Now what is the component of this one?
77.7.
Like you want what component is this? It is the adjacent component, right?
Yeah.
That is the y component. The adjacent component is the y component, so this is going to be 110 cosine 45. Doesn't make a difference if you make a mistake there because cosine and sine 45 are basically the same. So even if you mistake here, it's fine because instead of cosine 45, you wrote sine 45, you still get to the answer. Okay? So that is cosine 45. So this velocity has one vertical component, that's plus, how much is 110 cosine? 77.8?
Yeah.
And then what is the horizontal component of this? That's also positive, which is going to be sine of that, which is plus 77.8. And then you add them up. So 77.8, and that one is how much? Minus 400 and
22.2.
422.2. I'll leave it as this. 422.2 minus. And then what you do next is to make a new,
Yeah, it's 4.7.
I don't know. Subtract 550 from 77.8. 72. 472.2. And now draw a new diagram and represent this resultant's x component and resultant's y component on here. This is a positive thing, so that is a positive component of 77.8. And that is a negative component of 472.2. So you go down 472.2. Watch, I'm not putting the negative sign because the arrow is taking care of the negative sign. And then the resultant of this is here, which is what this one stands for. So you can see that you are on the right track when these directions are correct. Okay, so this is what you want to find out. What is the resultant? Square, add them up, take root. Do it.
478.
So this is 478 points.
6.
So 479 kilometers per hour.
Well,
Okay, you have to watch out how many sig figs are required. Then you do that, and then the next thing you want is the direction. Now, which direction are you going to refer to? Now, if you refer to this direction, this one here, you're going to say south of west, south of east. Now, south of east is okay. Or this angle will be much better.
Yeah.
With reference to the original direction of the plane, it's much better to say the other one, you know. So any angle, you can find out this or this, whatever you want. This angle here is the same as this one. Or if you find this angle, it is this. Find out this angle. So tan of the angle is equal to 472.2 over 77.8. Again, don't put minus signs over there. Even though this component is minus, don't use a minus because I've already shown the directions. I know exactly where the angle is supposed to be, so you don't have to bring the minus sign and complicate things. How much?
80.6.
80.6 degrees. And this is going to be south of east. If you leave that answer there, that's fine. But if you want to find this angle, then it's going to be the complement of that. If you want to find this angle, then it's going to be what? 9.4 east of south. 9.4 degrees east of south. Okay? Good.
How did you get the resultant again?
Square of this, square of Pythagorean theorem. Pythagorean theorem, like 77.8 square plus 472.2 square, radical. Now, those are all steps which are in almost all the problems. Almost all the problems you have to do exactly the same thing. You'll get the tan and make sure that you represent the angle. So if you're going to refer to this angle, you'll say 9.4 degrees east of south. Or if you're going to measure that degree, then you can say that. All right, next question. Anything else that is bothering you right now? Yeah.
There was a question on the homework where a basketball player is shooting a ball into a hoop, and he's like a certain height, and he throws it into a hoop that's taller than him, a certain distance away. And what's the total distance that it is?
It was 2.1 meters and he was 3.05.
Well, that changes according to the, like each one has different numbers. So yeah, you got a different number, he gets a different number. But they give you the velocity?
Yes.
Yeah. So what does the question ask?
It asks how far is the player away from the goal.
Oh, so basically the horizontal.
If he makes it. It said if he makes it.
How far it is. So you can just find out the x horizontal. That's basically your goal. So since they gave you the vertical height, since they give you the vertical displacement, you know, the ball goes like this and drops in. So that height, the net height, that's the vertical displacement. So initial velocity, if you're given the initial velocity, then initial velocity is v sine theta. Vertical displacement is known, acceleration is known. What more? Go ahead and find time. Now, since it is an angular projection, most of the time you will bump into a quadratic equation. And solve the quadratic equation, you may get 2 times, knock one of them out. Sometimes. Sometimes both times are right. So, depends on the problem. Knock one of them out, and then use the time to the horizontal side, and then x is equal to vt. That's all you do. Yeah?
Then the second part of that question asked about what is the angle as the ball, the angle as it entered the basket.
Yeah, so just like the bomb hitting the target, you do the same thing. The horizontal velocity does not change. The final vertical velocity, find that out,
Okay.
and then do exactly what we did for the bomb.
Okay.
Procedure is exactly the same for all projectile motion problems. It can be, in the form of a tennis ball. Someone serves the tennis ball, and the angle of the serve is like 10 degrees below the horizontal. And then it just grazes the net and lands that far behind the net. And if the question is like, what's the height from where he served it, or things like that, all you need is a proper diagram. Once you put a diagram properly and put all the information on the diagram, then you go to the table and start working it out, and it will all turn out right. That's the reason why I don't give you equations, ready-made equations for, all right, if you see a tennis problem, use this equation. If you see a bomber, use that equation. Like that, there are thousands of problems that you can actually, end up seeing. You can't be remembering all the different equations that are applicable for different ones. All you need is just the 4 equations of motion and the main ideas. That's it. The main concepts. That the horizontal does not change, the vertical only changes, and how do you find the angle, and how do you find the resultant. Those are all like basic concepts. Let's see. Let's take a realistic situation of a football player. So the quarterback is throwing the ball at a speed. Okay? The quarterback is throwing the ball at a speed and at a certain angle. So we need to put some angles here. So let's say he's throwing the ball at 40 degrees. What is approximate throwing velocity of how fast does a normal quarterback throw the ball?
No idea.
You should have an idea. What is this? You're watching the game and all those things. You should have an idea.
I don't know, probably
2 meters a second.
40,
No, 5
40
meters
meters
per
a
second.
second.
Okay, how fast is baseball thrown? Kind of 90 miles per hour.
Yeah.
And on that scale, is it somewhere there or lower? Much less. So how much do you put it as?
40.
Just give a rough idea.
40.
40.
15 meters a second.
Let's say 40 meters per second. 40 miles per hour. Now what you have is miles per hour, which is the speed that you normally have in mind, right? But we need meters per second. So what do? 40 miles per hour, you need to convert to kilometers per hour first.
6 2/3 meters a second.
No, to convert to miles per hour, you just multiply by 1.6, divide by 1. Miles per hour to kilometers per hour, multiply by 1.6. Do that. Miles per hour to kilometers per hour, you multiply by 1.6. And then from kilometers per hour, you're going back to meters per second. What do?
Divide by 3.6.
Divide by 3.6. And that will give you,
17.8.
okay, 17.8. Or let's say 18. So the ball is thrown at 18 meters per second at 40-degree angle. Now the question, so what exactly is going to happen? It's going to be going like this and lands, and the receiver catches it right there. Hopefully the quarterback and the receiver are the same height, so roughly it lands at the same level, okay? What is the horizon? So the first job that you do in any angular projection is to resolve. How much is this?
18 cosine 40.
How much? 18 cosine 40. Figure it out.
13 point.
Yeah, 13.8.
13.8. What is this one? Which is
11.6.
11.6
Yeah.
meters per second, and this is meters per second. Now, especially when you're doing mastering work and all that, don't round it off too much at intermediate stages. So don't think about too much about significant figures, okay? Like if it is 13.8, you can add one more digit to make it better. Because you want to round out the final answer to the appropriate sig figs, not in between. So if you write the 13.8 as 14, that's a big change. And your final answer will change a lot. Because you square this occasionally, you know. When you square a number, 13.8 square and 14 square is way off. And so keep as many decimals as possible. Like how many? One more.
13.79.
Okay, I'll put 79. What is this?
11.57.
I'll leave it there. All right. Now these are the two components. So what is going to happen is this is 13.79 meters per second is continuously going to stay the same all through. The vertical component is the one which is affected. It will change. What's the vertical component right there? Zero, and it comes down. Well, the question is, how far will it land? How far should the receiver be in order to catch it? How far should the receiver be to catch, so that he can catch it? So what do you do? Now split it up into horizontal and vertical. Split it into horizontal and vertical motion. Split it up into horizontal and vertical motion. What do you know about VI here?
13.79.
13.79. Is everyone agreeing with this?
Yes.
And if you're getting lost, and if you just simply go with the crowd, you will have difficulties when you try it yourself. So that's why your thought process should go along with everyone together. So when someone said 13.79 is this number, you should be like, okay, am I sure why that is there? Okay, what is initial velocity here?
11.57.
Good. And what else do you know? You want this. Displacement is zero. Displacement is 0 on this side, and acceleration is negative 9.81. Now, if you want to do a rough calculation, you can keep it as negative 9.8. And if you want it done more rough, take it as negative 10. You know what I'm saying? For multiple choice questions, your answers, if the answers are so close together, then you have to be very precise. So the answers are not close together, just throw 10 there, negative 10, and go on. It'll be much easier. Instead of writing minus 4.905, write minus 5. And then it will be making quadratic calculations and everything much easier. So we have this, and you can find out time. That T stands for how long is the ball hanging in the air. It's called the time of flight. Time of flight. You got to figure that out. All right, so to figure that out, you have to use the equation of motion, which is x is equal to VIT plus half AT squared. You can see I'm writing the equations on the respective side. I'm not writing that equation here. So x is 0 is equal to
11.57.
11.57
T.
T minus 4.905 T squared. It's not quadratic.
It's not.
Now, if this is not 0, then it's quadratic. If this is 0, it's very easy. Now, scoot this whole thing on this side, so it's 4.905 T squared is equal to 11.57 T. What do you do from there? Divide by T on both sides, and you can actually see that the equation is very simple. So time T is equal to 11.57 over 4.905. How much is that? 2.36 seconds. So now the receiver has 2.36 seconds to reach that spot. So what I enjoy watching the game is that first move. I don't care about what's happening afterwards. Afterwards is all crashing into each other and pulling face masks and all those things. What happens in the beginning is what I am interested in, actually. Like, I'm looking at the quarterback. Like, he's looking at all the options because he had a plan of some option, but that always doesn't go right, So he's trying to look for which receiver is at the right place, and so he's not throwing right to the receiver, right? He's not throwing to the receiver. He's trying to throw it at a place where the receiver will be able to reach in 2.36 seconds. So as soon as the ball is tossed to a certain location, the receiver should be able to go there and he should not be interfered with anybody. That's what the quarterback is doing. It's a pretty responsible job there. It's a very responsible job. Now, 2.36 seconds is a lot of time. And that means like, wherever he throws, everybody is going to run to that spot. There's a greater chance of someone taking it. So that is why in real football, when they pass the ball, they don't toss it at 40 degrees. They'll probably toss it at 10 degrees flat, right?
Yeah.
So all they want is a 10-yard through. So as soon as they find someone right next to them like that, they just throw it almost flat. So the ball goes almost like that. And the receiver is almost grabbing it before it hits the floor. So he gets what is required. And what is the advantage of throwing straight like that? The time. It doesn't spend too much time in the air. And that means like you can throw to a person specifically in the quickest way. Nobody can move after that. But 2.36 seconds is a lot of time. Yeah.
What if the receiver is running when he catches it?
He has to run. As I said, the receiver is not going to be here. The receiver is somewhere else. Now, if the quarterback makes a mistake, what kind of mistake he can do is he's tossing something up and he's giving the ball 2.36 seconds to land. And if the receiver is even running at Usain Bolt speed, he won't reach there. Okay? So that is gone. It is no good. You understand what I'm saying?
Yeah.
So he should do something that's practically possible and just possible. Not like the receiver goes and, okay, wait. No. If he's waiting like that, he's not going to be alone. Okay, so he has to do it in such a way that the receiver is going to that remote spot and will be able to reach. It's pretty interesting. Next time you watch football, look for the angles, look for, the techniques that I use. After that is all a mess. I don't know how they throw the flag for something I can't even see. So, it is tough. Because it's a big mess over there. I can't figure out who's having the ball even. Sometimes, they just like hold the ball and act as if they are passing the ball. And I'm trying to look, because everyone is running, and I'm trying to look at the wrong person. Oh, the ball is there. Okay. I was trying to look at the wrong person, holding the ball. Anyway, football is okay in terms of those things, but it is pretty rough. When I saw ice hockey, I thought football is better.
What?
Yeah, ice hockey is pretty rough.
Sorry, Jack. You're alone.
It's a club, no sport.
Blowing out my ear.
Ice hockey is much rougher than football, I think.
Jack doesn't play ice hockey.
Quick recall is a brain game. What is going to be the difference if this does not land here?
The vertical displacement is going to change.
If the receiver did not catch it,
It's gonna hit the ground.
it's going to hit the ground. So what is going to change here?
The vertical
Vertical
displacement.
displacement.
This is not zero. What is it going to be?
Negative
something.
the height is.
Negative something. So this is going to be a negative number, not negative zero. Okay. So this is going to be, so if the height of the person is like
2 meters.
so from the place he's supposed to have received to down is 1.5 meters. So that's going to be minus 1.5 meters.
And the final velocity.
Everything changes.
Yeah, everything.
Yeah. After you put this here, you're going to have minus 1.5 here, and now it turns into a quadratic equation, right?
Yeah.
Now the equation is 4.905 t squared minus 11.57 t minus 1.5 equal to 0. Now this is a quadratic equation. You have to solve it by minus b plus or minus root of b squared minus 4ac over 2a. So solve it and you get a positive answer, a negative answer. Take the positive answer and then put it down here and put it down here and all that stuff. So procedure is exactly the same except for this. Okay? I will show you how with only equations I can actually like show the entire thing without numbers at all. so that you can actually get some equations and all that. What angle should you throw a ball so that it goes farthest?
45.
Okay. If you have to do a problem where you're projecting something at an angle, let's say 40 meters per second, at an angle of 50 degrees, and this object goes in a projectile motion and it goes through a parabolic path. What you're going to do here is to split this 40 cosine 50, and that is 40 sine 50, and once you split it, the ball goes on. If the question was, how high does it go? How high does it go? So basically our problem starts here and ends here. We don't want to know anything about what's going on the other side. This is the initial position and this is the final position. We want to know how high it went. That means we want to know that. So what do you do for this? Horizontal, vertical, and then what is the initial horizontal velocity? That is 40 cosine 50. Initial vertical velocity is 40 sine 50. What is the acceleration? Minus 9.81 meters per second square. What is the other information we have is VF, the vertical final velocity at this point is 0 because the vertical velocity drops as you go up, and finally at this point is 0 and then it becomes negative as it comes down. So once you have the three things, you need to find out x, which is the vertical displacement. You can use Vf square is equal to Vi square plus 2ax. Vf square is 0. Vi square is the square of that, so 40 sine 50 squared minus 19.62x. And then we can bring this to this side, so 19.62x is equal to 40 sine 50 squared. And you can figure out x from there. And that's going to be the maximum height the object can go to. So for any problem, you need to figure out which is my starting point, which is my finishing point. If the question was asking for what is the total time of flight, which means your starting point is here and the finishing point is here. So you got to decide on which segment of the projectile motion are you going to focus on. So if it is only for maximum height, you go from here to here, that's it. If you want to go for how far it went, then you go all the way here. So in the previous problem, you had the time as 2.36 on this side, and then we transfer it to this side. So once you know the time and the velocity, you can figure out what is the displacement. Alright? So this is the basic idea of projectile motion, and you should be able to do all the problems in this way.